So Java 8 has been somewhat inspired by what's been going on in the context of Scala, and they have sought to respond to this to some degree by incorporating elements of these tools. And you recall that with our pipe and filter patterns, we had a very nice way to express successive patterns of computation, whether computed incrementally or in whole chunks. And Java 8 provides some similar methods, as we've just seen, to support this. The challenge here is that, as we know from a lecture 2 or 3 weeks ago, 3 or 4 weeks ago now, a challenge with those pipelines is when we have things that are nonlinear. They don't fit in neatly with the traditional framework, like exceptions or special cases, etc. And we talked about how in Scala we can use things, monadic types, things like option value or try, and there's actually one called either as well, to handle these. These basically retain metadata about the things being processed. For example, do we have a value or not? But they do so in a way that's that still allows them to be treated as values. Now, we're going to have, in a way that's required for graduate students, but optional for undergrads, a separate lecture on monads. And this lecture on monads is going to introduce you more generally to this notion of a monadic type. But the important notion that I want you to get, the important intuition here is a monad is like a container. It's like a wrapper or a package around one or more values, okay? This package, this wrapper, can maintain extra information, like is there a value inside me or not? Where did this value come from? In what coordinate system was it calculated? Those sorts of types of information. And we've seen in Scala, we had an option monad and a future monad that we explored. Turns out those same monads are present here within Java 8, okay, in a slightly different form, but very very familiar, okay. So here, like other monads, these things are going to retain metadata concerning the value, like is it present or not, or it's going to maintain is it done computing or not for futures, computable futures. It's going to be able to keep track and handle exceptional cases in a nicer way than traditional exceptions, and maintain sort of information through a series of operations. And the notion that I'm going to introduce of this in the lecture on monads is that these are, as one commentator put it, and it's a common expression now, programmable semicolons. You can basically use them to perform a whole sequences of operations, retaining extra information along the way without cluttering things up a great deal in describing the computation. It's as if you can program semicolons to accumulate certain types of extra information. So within Java 8, we have this notion of an optional value. This corresponds directly to our cherished, at least to me, options here within Scala, right? So if we have something like val, my option equals, and we do sum of 2, right? This is an option value, and as an option value, there's lots of things I can do with it, but one of them is that I could ask, is it defined, for example, right? And this is defined, whereas if I had set it to be none, it wouldn't be. So it is here. We can create an optional value using a variety of initial components. The equivalent one to sum is, we'd say, it's an optional of double, for example, of a certain value. So this would be a double value, for example. Or we'd say optional of double dot empty to indicate an empty value, none, using the Scala parlance. Very nicely, and this is sweet, to try to help start making up that billion-dollar mistake called null. You could say an option of person dot of nullable, and it takes in a reference to person. If that value is null, if that reference to a person is itself null, it creates an empty optional, one that's none in Scala parlance. It's empty. And if this of nullable is passed a reference which points to a real person, then it's non-empty. It is like saying of a certain person. And using these values, we can do things with them. We can ask, okay, are they present? That's sort of equivalent to is defined. We can get the value. If it's non-empty, we can do that. If it's it's not none in the Scala parlance. But we can also say dot or else. And here we provide an alternative value. If it is empty, the value on which we're calling or else is empty, then we'll use a replacement value, 0, something like that. Or we could say or else get and call off to a function, for example. We can map it, we can flat map it, we can filter it. So here we can apply these operations that we're used to applying in Scala on options. We can apply them instead on optionals. So just like we could have done, my option dot map, and here we'll, take this thing and multiply it times 3.0. So the same thing we can do it here in Java 8. Okay. Now it turns out that this is really sweet and part of the package because a lot of operations now return optionals. So when you have a stream and you say find any, is there any value that matches this predicate? It returns to you an optional, because there might not be one that matches it, right? Instead of returning null, if there's none that matches, it returns an optional. Find first. Well, maybe there's none, that's the first. It returns an optional that's empty, if so. We can ask for the max or the min. If the thing that we're asking about the max and min is itself an empty stream, it will return an optional that's empty, right? Reduce. We apply reduce to an empty stream, it will return a value that is empty. So optionals go along with streams in the sense that they result from a lot of operations. And so you could do something like this, right? I could say in some list, find any that matches this criteria and then map it according to this function. Or I could say within the list, filter out to only retain those who match this and then reduce it accordingly. Or, very nicely, if there's a person, I can ask get their spouse. Now maybe they don't have a spouse. Maybe they're single. Maybe they're not married. And in that case, get spouse to return something that's empty. I can then, for example, call get home on it, and that might then be applied. Okay, I should actually be doing maps here. Oh man, I don't know how that slipped through. But I'd be doing the map to get their home, get their address, do a map, and do get address on that. And it would be successively operating on these values where any one of them might have yielded none, in which case the entire thing would yield none, but otherwise it will apply it. So ladies and gentlemen, these should each have a map associated with it to be consistent, because we can't call it directly on an option. So at any point in the pipeline, an empty value will allow the rest of the pipeline to yield an optional that's empty, but if there is a value that is retained, we can continue to process it. And we don't have to have all sorts of special case handling. Is the spouse empty, or is the home empty, or is the address empty? Do they have a home? Do they have a spouse? Do they have an address? We don't have to deal with all those cases. We can just write it as a pipeline in a typical sort of way. Okay, so optional can allow for some compression of code that traditionally is rather long with special cases. Asking, is this thing null? If so, do this. Otherwise, do that. We can here create an option of nullable, this neighboring patches. If this is null, the result is going to be empty, and all the rest of this is just going to return an empty. But if it's not null, then we can map it into a stream, and then we could handle this case where it's an empty stream, for example, and map its neighbor according to some way, and then reduce it accordingly by summing things up, and that would replace this set of code essentially by this single line. Okay, it can handle these exceptional cases, these unusual cases that we have to handle just as part of the typical processing. So optional, ladies and gentlemen, within Java 8. The final thing I want to talk about, and I don't have time to go into this in any depth, is Java 8 does have the same notion of a future that Scala does. Here they're called computable futures. There's actually, confusingly, another thing called a future that strikes me as not nearly as powerful. And so here, with futures, we are, just as in Scala, operating with promises to future values. Okay? These are promises to a value that may be computed already or may not be. And so we can compose these promises. So if we have this thing which returns a future, and we could have another thing which takes in a value and returns a future, we could compose them together to something that performs the whole computation. Similar thing with then apply. We could use it in a similar way, and we could say when it completes, do this, undertake this function, or including handle a case of throwables. This throwable is quite similar to try within Scala. That try operation to handle values, we can handle it in a somewhat similar way with throwables here. So the advantages here, we avoid blocking computation. We just define these are the sequences of operations I want to happen, and go ahead and do them, and basically tell me by calling this function when they're done, or just let me check if they are done. And you can define and hold these computations. They could be underway while you're performing additional operations. You can store the computations in a place and harvest them later. Okay. So the example we used with futures was to compute long latency operations, and this is an example of scraping a web page and then applying some long operations successively that each return a future itself. So the entire set of operations can be undertaken over time, and successively the first can start up, and then it'll undergo this one, and then this one, and that one. You can refer to the results of the whole, and when it's done, that value will be ready, or it can call off to a function. So futures, computable futures in Java 8 correspond to futures in Scala. They provide a way of naming promises of future values, computing with them, operating on them as if they're a value, and having that value available when it's complete. Okay, so that's all we have for today. This is on Java 8 and its functional components. For the next lecture, we're going to begin the next section of the class, which is on class-based abstraction and using it in a safe way. Okay? Thanks very much.